Alright, so first you're going to want to get your normal formula equation for this double displacement reaction, which would be cobalt sulfate, and it'd be cation cancel across, and since cobalt has a 2, sulfate has a -2, they'd cancel out. Then you'd add aluminum oxide, which would be Al2, since oxygen has a -2, and a 3 down there, because the 3 would cross over from the aluminum. And then you do the double displacement, so it'd be aluminum sulfate, so you'd have aluminum SO4, since the 3 would cross down to there and the 2 there. Then you have cobalt and the oxide, and the 2's cancel. So cobalt sulfate would be aqueous.
These are the solubility rules.
Yep. And aluminum oxide would be solid. And then aluminum sulfate would be aqueous. And cobalt oxide would be solid. Then you want to go back and balance it. And the balancing would be 3 blank blank 3. And then you'd go from your normal formula equation, to the complete ionic equation, which would be breaking up the aqueuses into 2 parts, and then your solids stay the same. So it'd be 3 cobalt plus 2. And then next you'd go to the net ionic, which is taking out the things that stay the same throughout the reaction. So the sulfate doesn't change from the reactant side to the product side, so that would be taken out. And the solids still stay the same in this one.
Okay, and then for the next step, you're going to have to be finding the limiting reagent. And you're going to start.
And then the spectator ion is the one that didn't change from the reactants to the products, and the spectator ion would be sulfate.
And you're going to first.
And let's just show that. Where's the... Wow, what's that, sulfate?
Yeah. Sulfate is there, and it's 3 sulfate, -2 here, and 3 sulfate, -2 there. They're both aqueous,
Okay.
so they didn't change.
So from across the reactant to product side, if you have a reactant, that's the exact same as a product, not
Yes.
only in composition but in material state.
Right. It is a spectator ion.
Zinc hydroxide and barium sulfate undergo a double displacement reaction. Now for the next equation, the complete ionic. None of the products here are also the exact same as the reactants, which means spectator ions, there are none.